Good wishes to all. Today we are going to design a square footing such that it is subjected to a load of 150 kilopounds with foundation placed at a depth of 3 feet above the saturated clay layer with cohesion value as 1100 pounds per square feet, angle of internal friction as 0 degree and density of soil beneath as 110 pounds per cubic feet. We have coefficient of volume change MV, that is 0.01 feet square per ton, and coefficient of consolidation CV as 0.002 inches square per minute. We are asked to determine the safe bearing capacity such that the footing designed is with factor of safety. Clay layer is at a depth of 15 feet below footing. We need to calculate the settlement of odometer using 2:1 load distribution method. Value of coefficient of volume change remains constant. Let us assume layers to be divided into number of 5 and final settlement is 75% such that initial pore pressure is uniform and we have a clay layer underlying. To begin with, using Skempton's equation, we'll determine the value of NC since depth of foundation is 3 feet and in case of a square footing, our B by L ratio is equivalent to 1. So from here we get the value of NC as 6 bracket 1 plus 0.6 by B. Next step is to determine the net ultimate load. Formula for that is cohesion multiplied by NC, that is bearing capacity factor. So we have the equation as 1100 multiplied by 6 brackets 1 plus 0.6 by B. This is our equation 1. We compare it with the value of applied load, that is 150 into 10 raised to power 3, since we have load in kilopounds, divided by area multiplied by factor of safety. So this gives us the safe value of the load. When we equate these two equations, from there we can compare these equations and get value of B, that is breadth of footing, approximately equivalent to 8 feet. Next step is to determine settlement of odometer and to determine delta P. This delta P is our change in pressure and we'll be determining it using 2:1 slope distribution method. So for that, first we divide the soil layer into 5 layers of 3 feet each since we have the depth given as 15 feet in the question from the base of the footing. This is the diagram that represents the division of soil layers. For that, first we need to understand the formula for determining change in pressure, delta P, that is Q upon B plus Z whole square. B is a breadth, Z is a influential depth which is usually taken from base of the footing to middle point of the layer. Delta P, in case of first layer, it would be 150 by 10 cube as it is kilopounds divided by 8, that we have already calculated this as breadth, and 1.5 because from this base of footing, first layer is 3 feet of depth and middle point is calculated up to this value, it comes out to be 1.5. Similarly, we calculate the change in pressure values of each layer. 1.5, middle point up to second layer, total from this point it comes out to be 4.5. In case of third layer up to this point, this distance comes out to be 7.5. In case of fourth layer, distance over here, this comes out to be 10.5, and in our last layer up to this point, distance comes out to be of 13.5. So we can calculate the change in pressure in varying layers